Alright, so in this video we're going to go through finding a derivative using the definition of the derivative. Now I'm not going to go through what a derivative is, defining it as instantaneous rate of change is a term you might have heard before, or the slope of a tangent line to a curve. I'm not going to go into all that. We're just focused on how do you calculate a derivative using the definition. Alright, now this right here is the technical mathematical definition of what a derivative is. It's the limit as x approaches a of f of x minus f of a over x minus a. Now I typically use this notation for derivative f prime of x. Some places you might see this as being your term for derivative, dy dx, right? But just know those two notations are the same, right? I don't want you getting confused depending on whether or not your class uses something different. So what we're going to use is a somewhat modified version of the definition of a derivative. Here, f prime of x is equal to the limit as h approaches infinity of f of x plus h minus f of x over h. All right, so let's just start going through some examples. All right, so here we have a pretty basic example, right? We have a function f of x equals x squared plus 4x minus 2. Now, you might have some other method for doing it. There are a bunch of shortcut methods. If you're familiar with derivatives, power rule would obviously be your go-to method here. But it's also important to know how to do things straight from just the definition, right? The reason we know things like power rule work is because of the definition of the derivative. All right, so let's just line that up there. Okay, so first we're going to substitute our function into our definition. So the derivative of f of x is equal to the limit of f of x plus h minus f of x over h as h approaches 0. And we start substituting. So let's substitute in our f of x plus h. What we're essentially doing is anytime we see an x in our original function, we replace it with x plus h. So this gets an x plus h squared plus 4x plus h minus 2. And then we subtract that by the original function. Okay, so I didn't leave myself a lot of room here, but all right, I'll just grab myself an extra piece of paper to kind of write across. So we subtract that by the original function. Now it's important to keep this in parentheses because you'll need to distribute this negative sign out. Otherwise you're not going to get the right answer. X squared plus 4x minus 2 all over h. And we can't forget our limit. Now, we can't just put in 0, otherwise we're going to get a fraction with 0 in the denominator, which is something you can't do. You can't divide by 0. So we're going to try to expand this out and eliminate certain terms. All right? So let's try to open up all the parentheses here. And I'm going to write right here. So expanding this out, if you were to do x plus h squared, you should end up with x squared plus 2xh plus h squared. Distributing this 4 will get us a plus 4x plus 4h. And then this negative 2 just stays as a negative 2. And then we distribute out this negative sign here. And we get minus x squared minus 4x and plus 2. Sweet. Okay, so now really no need for that one sheet of paper. And that's all over h. Now let's just start eliminating like terms. All right, so this positive 2 and this negative 2 cancel out. This negative x squared, this positive x squared cancel. The plus 4x and minus 4x cancel. And we're essentially left with two xh plus h squared plus 4h, and that's it. Now from here, we can start eliminating like terms. So we have an h in every term in the numerator and an h in the denominator. So we can just eliminate those. And the thing we're left to compute the limit of is the limit as h approaches 0 of 2x plus h plus 4. And substituting in 0 for h gets us 2x plus 4 as our final answer. All right, so that is essentially, if they ask for the instantaneous rate of change, slope of a tangent line, that's what this equation is. All right, so here's our second example. We're going to find the derivative of x over x plus 1. So this one's going to be a little messier as far as the algebra goes. However, everything outside of that will essentially work exactly the same. We're going to start off with, all right, what is our definition? So we're looking for f prime x, and that should be equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. All right, and we substitute. So we're going to get, so f of x plus h is going to be x plus h over x plus h plus 1 minus our original function, x over x plus 1 all over h, right? And we're taking the limit of it. I keep forgetting to write it, but keep in mind we always have that limit there. Now, obviously we can't just put in 0 for h, right? Same issue. The issue you're always going to come up with is you're going to get a 0 in the denominator, something you can't do. So you're going to need to simplify things. In order to do that, we have to combine these fractions. So in any level of math, even calculus, adding fractions and the ability to add fractions, super important. It comes up a lot. So you're going to need these to be like terms. How do you do that? Well, you need to multiply this from on the top and bottom by this denominator, x plus h plus 1, right? So I multiply this by x plus h plus 1, and I multiply the top by x plus h plus 1. Here, I have to multiply it by x plus 1. So this gets multiplied by x plus 1, and here I multiply by x plus 1. So now I end up with this three-tiered fraction of x plus 1 multiplied by x plus h minus x multiplied by x plus h plus 1. And that's over my common denominator, which ended up being x plus 1 and x plus h plus 1, all over h. Now, how do I get rid of this complex fraction? Well, I can multiply, what this essentially is this fraction here divided by h. How do you deal with division with fractions? You just change it to multiplication. You multiply by the reciprocal. So instead of dividing by h, I'll just multiply by 1 over h. So this is going to be x plus 1, x plus h minus x plus h plus 1, and that's all over x plus 1, x plus h plus 1, right? And I'm multiplying by the reciprocal of 1 over h. Okay, so now what I'm going to want to do is start to multiply this stuff out, right? Because I still have an h in the denominator here, which if I were to substitute 0, I would still end up with a denominator of 0. So let's start multiplying this numerator out. So first, just distributing, right? Normal process of FOILing. You'd get this first term to be, so we have the limit as h approaches 0. So x squared plus x plus xh plus h, right? And then similarly here, by distributing this x to every term in here, you're going to end up with, well, distributing essentially a negative x, right? You get minus x squared minus xh minus x, all over that same denominator of x plus 1 over x plus h plus 1 times h. So let's start eliminating like terms, right? We can cancel out. All right, so I didn't realize part of my video got cut off. So the only thing you really missed out on is this top fraction, which was which I got after simply multiplying these out, and then I just canceled like terms, leaving us with a very simple fraction of 1 over x plus 1 times x plus h plus 1. Now this is something we can take the limit of. All right. So all I'm going to do is substitute in 0, and I'm going to get 1 over x plus 1 times x plus 1. And that would be your final answer. That would be the derivative of your original f of x function. Right? You could multiply this out, but also alternatively, you could just leave it as x plus 1 squared. All right, so for our final example, we're going to look at just the derivative of the of rad x, right? We're going to find the derivative of rad x, and also we're going to compute the derivative at x equals 9. Okay, so sometimes they might ask, what is the instantaneous rate of change at a certain point? This is how you would do it. So first, let's focus on just calculating the derivative using the definition. First, we're going to write down our actual definition of a derivative. So limit as h approaches 0, f of x plus h minus f of x all over h. So limit as h approaches 0, we're going to substitute, right? So instead of rad x, it's now rad x plus h minus the original, rad x. And that's all over h. So this looks a lot simpler than the last one, but we run into a problem. There's nothing to simplify. There's nothing to cancel out, right? So how are we supposed to get rid of this h in the denominator? We can't take a limit yet. So this should be somewhat familiar if you've done complex numbers, right? Or if you've ever had to rationalize a denominator, we're going to multiply the top and bottom by the conjugate of this numerator, right? That'll get it to a different form, maybe something we can work with. We'll see. So multiplying by the conjugate on the top and bottom, we get rad of x plus h instead of minus, plus rad x, and we do the same thing to the bottom. All right. Now, from this point, this is essentially difference of two squares, right? This is the end product. It's, a minus b times a plus b. So the final answer should be a squared minus b squared, right? If you were to do it the long way where you FOILed, you would get the same answer. So we have x plus h minus x as our numerator, and in our denominator, h multiplied by rad x plus h plus rad x. All right. From here, we can actually find stuff to eliminate. This positive x and this negative x cancel out. And now we're left with just an h in the numerator. And then we also have an h term in the denominator, which we can cancel. Now, we're left with something we can take the limit of. So the limit as h approaches 0 of 1 over rad x plus h plus rad x gets us 1 over rad x plus rad x, or 1 over 2 rad x. So now we have the derivative. Okay, so now to compute the derivative at x equals 9. So one mistake I've seen a lot of people do is they'll take 9 and put it into the original and try to manipulate it that way, which is just not the correct concept. But once you just get the method down, it's super easy. It's essentially just substituting, right? We're looking for f prime of 9, right? So what is f prime of x? We've already determined that f prime of x is 1 over 2 rad x. So f prime of 9 should equal to 1 over 2 rad 9. Simplifying, rad 9 is 3. 3 times 2 is 6. So our final answer is 1 over 6 for calculating f prime of 9. All right, so that's how you compute the derivative using the definition. All right, so main takeaways is this is essentially what you're using. You're going to take whatever function you're given and substitute it in for these two components here, right? This is essentially your original function. This is your function where you essentially replace every x with x plus h. And from there, you find a way to simplify, right? Either you, like in our first example, distribute and then open up all the parentheses, and then a lot of stuff will cancel out. If you're dealing with fractions, make sure to combine them, add them together, subtract them. And then if you're dealing with something you can't simplify, look to see if you can manipulate it another way, such as multiplying by a conjugate. All right? If you have any questions, just throw something down in the comments.